Hello, I'm Robert, a fact checker and science blogger, and this time I'm talking about this story that's just come out. The tropical forest carbon sinks already rapidly weakening, which sounds quite scary, but it's not at all what it seems to be. So I'd like to explain a little bit carefully what it means. It's very significant for experts to look at, but the trouble is it's just been rolled out to the public. We don't really know how to make anything of it, and they're made into kind of clickbait titles. So first of all, this is about only about trees above ground level. So you can see there, this is how they did it. It's measuring trees and looking how tall they are and things. So, and then what they found out was that the tropical forests, they were moving, so every year, so what's been happening, you see, is that because the climate is warming, and because there's more carbon dioxide in the atmosphere, trees grow a little bit bigger than they used to. So if you go and measure the trees in the tropical rainforest today, you find your trees a little bit bigger than they would have been if you'd measured them in the beginning of the 20th century. And this has been rather fortunate, because as we're adding more and more carbon dioxide to the atmosphere, the tropical rainforest trees have been growing at the same time, and they've taken down a fair bit of the carbon dioxide. And in the 1990s, these intact tropical rainforests were moving 70%, nearly a fifth, of the human-made carbon dioxide just by growing bigger, because there's more carbon dioxide in the atmosphere and it's a little bit warmer. And every year it's a little bit warmer, a little bit more carbon dioxide, and the trees grow a bit more vigorously. And then that means that the trees have got more mass in the trees above the ground level. So what this study is saying is that that these trees are not now growing quite so fast with the increase of carbon dioxide as they were before. And part of the reason is that some of them are dying because it's just being rather stressed, being a little bit warm. And so that's the dying ones, of course, just standing timber, and they're not actually growing anymore. And so as a result of all these effects, then it's so only a bit of it is because of the reduction in how fast the trees are growing. They're still growing quite a bit faster as the atmosphere gets more carbon dioxide, still having a fertilizing effect. The warmth is increasing the growth, but it's increasing at just 2/3 of the rate that it was increasing before. And most of that decline actually is in South America. And in the Congo, it's not happening so much yet. That was delayed by about 15 years or so. The trees there have been more resilient. And so the Congo, although it's a third of the area, is actually taking up about half of the tree mass carbon dioxide. So, and then they're worried that in South America, in the 2030s, then it'll have got to a point where the trees are no longer taking up anymore, they're no longer getting bigger. The chunk is no longer getting larger all the time, it's sort of become stable, and then might start shrinking a bit because of dying trees. And in the Amazon later on, in the Amazon rainforest, it's going to transfer to savanna at about 3 degrees C, but of course shrinking quite a lot. So in the Congo, it's all rather later than that. It's continually taking up more carbon dioxide. So, but this is just one of many things going on, because they're not taking any account at all of the carbon sequestration in the soil. Look like somewhere in the UK where I live, then you have grass almost everywhere. Grass, mosses and things is constantly raising the height of the ground a little bit every year. If you've got just fallow ground, and you're not constantly ploughing it, and you can go and look at the ancient Roman ruins, then they're meters down. You're a couple of meters down. You have to dig really quite deep. I did a bit of archaeological digging just as a volunteer when I was in my teens, I think it was. And I remember that these digs were really quite deep in the ground. And even the Vikings, if you go to the Viking exhibition in York, then it's really quite deep. So So soil is quite a good carbon source, carbon sequestration. Grass is taking up it all the time. That doesn't happen so much in tropical rainforests because they're very thin soil. But in some rainforest areas they do. It does happen. There's large areas that were used for agriculture and biochar, and where it is raised up soil. So they just haven't taken any account of that. And they aren't taking any account of the roots. They're just looking at what's above the ground. And then there's the terrestrial sinks. And then nothing in account of reforestation. This is only about virgin, intact tropical rainforests and what they are doing to climate. It's nothing to do with deforestation and reforestation. That's looked at separately. And in all the continents except South America and South Africa and southern sub-Saharan Africa, then there's actually more reforestation going on than deforestation. China has got a huge increase in the forest. It's going on there, very, very rapidly increasing. So this is not taking account of that either, of course. And then another thing it's not taking account of is that in the entire northern hemisphere, then the growing season is getting longer. And this leads to there being more mass in the trees and the pastures, grassland. There's more mass in the grass. It's sequestering more every year than it used to, because the growing season is longer, so it's more time to do it. And then you've got the greening of the Arctic and and Siberia and things like that. Then that also is having an effect. And so they actually mention this in the paper, and they say there that that's a bit about the Congo basins being very important, and they're saying that given that the overall global terrestrial carbon sink is increasing, now that means that every year the land is taking up more carbon dioxide than it did on the previous year. So this year, the amount of carbon dioxide that will take up in 2020 of all the land will be more than the amount of carbon dioxide it took up in 2019, and that was more than in 2018, and so on. And so given this increasing, although the weakening effect from the intact tropical forest sinks means there has to be something else that's doing it outside the tropics. Well, they haven't actually proved it's outside the tropics, because it could be soils in the tropics and agriculture in the tropics and sea in the tropics, but they have independent observations that the atmospheric carbon dioxide concentration that suggests that the carbon intake is increased in the northern hemisphere far at a greater rate than the global terrestrial carbon sink. And it's increased even more disproportionately, in other words, even more of a northern hemisphere effect in the 2000s. So all this suggests something's going on in the north. It's probably things like the lengthening growing season I was talking about, and the greening of the Arctic and what do you call it, the subarctic, the region around the Arctic, where there's a lot of greening going on. Yeah, so I talk about that a bit there. And so then the end sentence, they say, in international level, given that tropical forests are likely to sequester less carbon in the future than Earth's system models predict, an earlier date by which to reach net zero will be required. But it's exceedingly speculative. They really mean just an earlier date due to this effect. But other effects, obviously this increasing terrestrial sink in the northern hemisphere has to be taken into account. That means a later date. So it's an earlier date from the tropical rainforest, yes, but a later date from whatever's going on in the northern hemisphere. If that is increasing more than these things seem to, than they expected, and they said there's been a big increase since the 2000s. So there's lots of stuff to be looked into, and then so this has just been going around with these people saying the Congo rainforest is losing ability. It's the Washington Post article. The Congo rainforest is losing ability to absorb carbon dioxide. Oops, that's bad for climate change. But they don't really give the context. They don't mention any of this. If you go to the paper, And as I say, it briefly mentions these things I'm talking about. They say that it's only above this, it's only the tropical intact tropical rainforest above ground level, and that it's not including the northern hemisphere. But these articles started by journalists don't tend to mention that. If you want to read the paper, go to this article, click through, and then you can click through. I'll do it right now. And then if you click through here, you can find the paper. This is because I'm in the. I'll just do browse now. I'm in the. If you go to the free, I've actually got a subscription, but this is because I'm deliberately doing this private so as not to show notifications on the crawler and so on. But so if you don't have a subscription, then you only. It's not going to let me see it in that. I'll have to bring it. I'll bring it up another page. Let me show you my subscription version of it. Okay, so you only get to see a few. If you haven't got a subscription, you only get to see a few pages of it. You only get a few pages before it tells you you've run out. So, but if you have got a subscription, or if you only haven't watched many Washington Post things, you just go down here and then you click. It says a study published yesterday. Click there. And then if you wait a little while, then you will get the full paper there. And so it's something to watch out for. There may be other articles about it that will do the same. It's the only one I know about about it. So the whole one, it should do in a minute. Here we come. Here we are. You get this little thing comes up, and then it shows you the entire paper. So you can read quite a lot of papers like that. Even though it's behind a paywall, they make them available for links from the news sites, and they also make them available via links from the authors' websites. So you can sometimes go and look up the author, go to their own website, and they'll sometimes provide a link to their paper in the same way. You can go and read the whole thing properly. So this is a useful tip for nature articles especially. And then you can go and read it properly. Those bits I was telling you about. They talk about how do you need, and so this is the other thing I wanted to explain. I mentioned it in my article, but I'll just go there. That this is a prediction that the sink will continue to decline. It's not actually proven. So it's declined so far. The question is it going to continue to decline? And so if it's just published in all the journalists are just saying they have proof, they're saying it's going to decline, as if they'd proven it, they haven't. So in order to test there's a prediction that has to be tested. And the reason it's not confirmed for sure yet is because there are many other climate variations that as the forests, there's a variation that can be about 70 years of the climate in the Atlantic, the ocean, the Atlantic multi-decadal oscillation or something like that. There's an oscillation about 30 years in the Pacific. There's El Nino and La Nina thing that everyone knows about, but there are other ones as well. So quite a few large-scale climate changes and oscillations back and forth. There's one that involves Australia as well. It's for several years, and all these things combined together obviously affect the forests. And so they haven't tried to disentangle all the effects of these. They've just done a very simple thing, just gone and measured all the trees every year, sort of spot checks, through the years. From the 1990s is when, in the 1990s when the trees were increasing in mass the most, but now it's been decreasing. But could it be because of some other reason? Could it be because of some of these other seasonal effects? So they don't actually know for sure. And they have a prediction that it's going to continue to decrease, and because we cannot exclude the possibility of decadal scale climate impacts on these forests. And such direct ground-based measurements also provide a constraint on estimating the size, location and climate sensitivity of the terrestrial carbon sink. And so it's not actually proven yet, although it does seem quite fairly solid research, but it's not absolutely waterproof. So right, so a few other things I wanted to say is that so first of all, on the whole carbon budget thing, this is a paper. Think of it as a conversation. Lots of physicists and climatologists and scientists and biologists and so on talking to each other through nature. And if you are a distinguished professor, then you can go and write a paper for Nature and they'll publish it if you've especially got a very good track record. And then for them it's almost like writing a letter, for the very distinguished ones. And almost anything you write goes into Nature. So and then they have a chat with other academics, but it means they've thought it through carefully, and they put all the footnotes for everything. They say this, and little footnote, this, and that's the way professors write letters basically on Nature. So think of it more like professors writing letters to each other with lots of footnotes, and then that is sort of how Nature works, along with some of their postgraduate students who sometimes are doing the work, and then for the student it'll be that kind of highlight of their academic career so far, that they got their work into Nature and they spent years on it and working on their thesis, and then they make it a paper and it goes into Nature, but it's still just hypotheses. This is a hypothesis. This is not proven. That something appears in Nature doesn't mean it's proven. As I just read out, it's a prediction that hasn't been proven, that needs to be tested. And then when we get to, say, 2022, so a lot of people just don't realise this about Nature. And they just think if it's in Nature, it's true. It's established, everyone agrees. And that's not really how it works. And this paper is just like people chat about the professor writing in spidery writing at the bottom, that the budget will have to be adjusted because of this. It's just this view he's written in a letter. It really doesn't mean a lot. Not a little comment like that without any calculations, no calculations associated with it, no footnotes, just a remark that he sort of typed. He sort of thought as an aside and he wrote at the end, and then people just thought, oh, he's a distinguished professor, he's put a lot of interesting stuff in there, and it's an interesting remark. We're not going to remove that, we'll just leave that in. And it's obviously going to have some effect on the carbon budget, but it's not really likely. Okay, that'll maybe push the net zero back a bit, but other things will push it the other way. So it's just him making his little point from his very small detail of the entire picture of the entire world. And really, you don't really need to focus too much on these nitty-gritty details anyway, because the big report in 2018, the main thing they were saying is that every half degree matters. And so we've already pulled it down to a degree or so since whatever it was. We don't know what the exact numbers are, but say it was 4 and we've reduced it down to 3 just because of the Paris Agreement. And then Europe is going to put it down another degree and a half if we commit to zero by 2050. Anyone who commits to zero by 2070 is putting it down another degree, below 3 degrees. Now whether it's literally from 3 degrees to 2 degrees, whether it's from 3.4 degrees to 2.4 degrees, or whether it's from 2.6 degrees to 1.6 degrees or something. I mean, some people, the one Russian model has the climate sensitivity that we think is 3. The consensus, the thing is, people just take as being the climate sensitivity is kind of average of everything that seems to be best fitting everything we know. But I mean, one recent climate model at 1.8 something, 1.86 was that climate sensitivity, in which case we are already below 2 degrees C just by what we're doing already. Now you can't do that. And the same way though, you can't do it the other way and say, oh, we're headed to 4 degrees or something. Our best guess is that it's 3 degrees, that's what we work with. And that it's not just guessing as in, I think of a number. It's our best hypothesis, our best scientific understanding on the basis of all the facts that we've got. Then is 3 degrees C. And all our previous reports have been like that, and just continuing like that, we tend to have narrowed the range into the middle of what the previous report was. So it likely is 3 degrees C for what we're on at the moment, and it likely is about 1.5 degrees C that what we're headed for with zero emissions by 2050. But it's far more important that if we go to zero emissions by 2050, we've knocked half a degree of 2070, and the roughly, it could be equivalent, maybe 0.4 degrees, maybe it's 0.8 degrees, we've knocked a fair bit off. And then the big finding of the report in 2018 was that every half degree matters and makes a big difference. And for instance, between 2 degrees and 1.5 degrees C makes a huge difference to the corals. Most systems are not very much affected. And it does make quite a big difference to the aridity of the process of semi-arid going to desert in places like Spain and Turkey, for instance. It's another thing where it makes quite a difference quite early on. And so there's various things just not everywhere in the world, and then they of course can also work to mitigate that, and you can work to try and stop to help the corals to adjust, and the corals may evolve a bit as well, and then the various things you can do to try and help them. So we do both, but certainly if we can reduce it to well below 2 degrees C, then the impacts will be much less than if it's significantly above 2 degrees C, and that's significantly less than if it's our current of 3 degrees, and our current of 3 degrees is very significantly less than if it was 4 degrees, which is what we would be without the Paris Agreement. And you get all these activists saying, oh, nobody's doing anything. Look, we haven't got down to 1.5 degrees. We haven't got down to 1.3 degrees. We've got to reach carbon zero by 2025, some of them will say, or by 2030 or 2045. But every bit that we do is helping. And our current policy of 3 degrees C has already made a huge difference. So it's much more, I'm absolutely amazed at what's happened in the last 5 years, having followed it since before the subject began. So in the 1960s, when I first got interested in science, and it wasn't taken so seriously back then, but there was the idea that we were headed for an ice age, based on very rudimentary understanding. We just didn't really understand things well at all. We thought that probably all the ice ages the interglacials must be about the same duration, about 10,000 years. It's been 10,000 years since the last one. Basically, that very crude kind of rough guess. All the others are 10,000. This will probably be 10,000. So we might be headed for an ice age even this century, or next century. And Asimov did a very fun story about that, just a very short story, in which the ice comes back to London. Big glaciers. It sort of speeded up and made a fun story out of it. But so I've been around since the subject began, before people even knew that that we were headed for global warming. They thought it was a random walk, and then we might end up in an ice age in the very near future. And so, but about the 2070s and 2080s, with the Milankovitch cycles, and people began to realise what was going on, and since then we've been tracking their predictions for the 2070s even, pretty well to today. So by then, it very quickly matured enough to make predictions, and they made mistakes, but it's a tendency for small mistakes to counteract each other. If you have a fair number of mistakes, then some of them will be exaggerated one way, some the other way, and they tend to kind of counteract each other, and that is basically what happened. And so it's probably much the same now, that okay, maybe we've made a bit of a mistake with tropical trees, that we weren't expecting. We were expecting them to grow a little bit faster than they are, and they're only growing about 2/3 of the increase in mass than we were expected. But the other places where we made mistakes the other way, and they tend to kind of average each other out, and you end up just narrowing down in the middle, even though you're making mistakes, just the way it tends to go. And it's not guaranteed it does that, but it just tends to. And so anyway, so that's all it's no scientific, so you can't prove that's going. It's not definitely going to happen, but it may well be that we just headed 3 is definitely our best guess. We've got no better guess than 3 degrees C. until the next big model, big IPCC review. And this certainly hasn't changed that. Yeah, this is that Russian thing I was telling you about earlier. And I'll just bring it up. There we are. Here we are. So you get all these people talking about, oh, these new climate models, they say we're going to be well over 5 degrees C when we expect to be 3. And you don't get these journals going up, oh, these new climate models, they're saying it'll be nothing like 3 degrees C. Look at this one. It says it's going to be only 1.8 to 3 degrees C rise if we continue with what we are. And these are no more credible than those at this stage. And it's likely somewhere in the middle. Probably about 3 degrees C. You don't just kind of average those, they may well have made the same mistake. Or the same thing, they're not really modelling quite correctly. So you do need to watch out for these headlines, because the journalists always go for the ones saying, oh, things are worse than they seem. And they don't go for these ones, they just don't mention them, or very rarely. So then another thing is, so there's, as I said, this new study didn't look at all at reforestation. So I've got these links, I've already talked about in videos, good things going on, a lot of reforestation going on. There's this Dare to Hope climate restoration thing. These are various possibilities of huge ways that using nature and using other methods as well, you would take vast amounts of carbon dioxide out. For instance, with giant kelp seaweed farming, or with various ways of hugely enriching the world's soils. So people say, oh, we couldn't get all the farmers doing that. But there are various methods that if you could somehow get lots and lots of farmers to do them, they would hugely increase the amount of carbon in the soil, and that would make a big difference to taking carbon dioxide out of the atmosphere. But people just tend to somewhat give up and say, oh, we can't get all these small farmers to do that. But if you can make these things economic and actually helping them beneficial for them financially, or beneficial in terms of their crops, and at the same time increasing the carbon dioxide sequestrations of their soils, there's actually quite a huge amount of possibility. For instance, biochar, but there are other things as well. So there are quite a lot of ways we could actually end up with but I think the giant kelp seaweed farming is one of the fun ones that really does have a lot of potential, but we have to see where that's going. I think it's most important to look at the next 10, 20 years, 30 years. Beyond that, it's very hard to know, because it's quite possible that something could come up that becomes a really big thing, like seaweed becomes a really big thing, and suddenly everyone's growing huge farms and farms of seaweed, and somebody comes up with a clever way of doing it that's very economical and produces vast amounts of seaweed for very little cost, and then that could be spreading over all the ocean gyres. That would make a huge difference. So, and all these things do actually pay for themselves according to their preliminary calculations. So that's something to look at. And then, so I think it's very important that that's just that's a core article. Sometimes happens. We just get outage from time to time. Okay, so better not refresh any of these windows. Anyway, I think I'm about finished. But if you go and have a look at that, then I'll just have a little look before I finish. But it'll be up again in a few seconds, probably a few minutes too. But this was a study that looked at the Brazilian rainforest, and then in the 2020s, then it looks like with just the improvements of the efficiency of agriculture, of the Brazilian agriculture, then even with increasing yields year on year, then according to this model, which is one way of modelling it, then we can start having areas of agricultural land that actually get abandoned. This would usually reduce the pressure on the rainforest, and then if they start reforesting these abandoned land, then they reckon that a lot of the carbon dioxide that was lost from the deforestation, eventually all of it, can be taken up with reforestation of abandoned agricultural land, which you can reforest with tropical rainforests, maybe along the rivers, and commercial plantations as well, which gives an extra income for the farmers. And then improved agriculture, improved grass, and of course soil sequestration as well. There's such a huge amount we can do. So we really, when you look at this, just think this is just one little detail, and there's vast amounts that we can do. And just, I think we actually need a glass half full approach to climate change, not a glass half empty. That so much that we've done so far, we're only halfway there, but the glass is half full. We have done a huge amount already in just the last 5 years. Absolutely amazing what we've done and what is going on around the world. New projects all in the last 5 years. Huge reduction in cost of renewables. Massive innovation. Anyway, that's enough for now, and hopefully that's helped some of you who worry about climate change, and especially anyone who worried about this article. And it's not something for the public. In fact, I think that they should make it rather clearer to the public how tentative these studies really are, how interim they are. Interim's a good word for it. And the journalists, they just take any kind of study that looks scary, they run it to even this is a very high quality one. So don't get me wrong, this is very high quality research. I'm not saying it's low quality. This is just that this is the nature of the subject. And just so high quality research in Nature, it isn't a Nature opinion piece, it is a proper Nature scientific paper with loads of footnotes, very carefully done. But it's just one small piece of the puzzle, and it's one part of a dialogue, and it's not even conclusive. They've made a prediction which now needs to be tested. And it's the general picture is that the terrestrial sink is increasing year on year. Indeed, it's increasing rather more than expected since about 2000, and nobody's quite sure exactly all the details of why that's happening. And this is one of the details which is actually pointing the wrong way, so this is sort of not really explaining it. It's almost more like a puzzle. Why is it increasing? Why is this sink continuing to increase when this particular study it seems to show it should have decreased? From 17% down to 6% for the tropical forest. Something else is taking up 11% and more, because it's actually increasing. So there's something else there that's doing quite a lot, that is compensating for all this. And we need to know what that is, but not us personally. The next IPCC report in 2022 is the next opportunity to look at the carbon budgets again, and in a really big way. But I don't expect it to change significantly. It's probably just narrowed down, and if it does change, well, the last one, it actually found there's more carbon dioxide, sort of like finding coins under your carpet or something. They found that we've got actually much more carbon dioxide to spare than we thought we had, if for the particular targets. Not that anything you want to stop. If we can reduce it to 1.3 degrees C, that'd be brilliant. But it's easier to get to 1.5 degrees C than they realised before 2018. You could stop at 1.2 degrees C, wonderful. But 1.5 degrees C is a reasonable target that we can achieve with gradually increasing the Paris Agreement pledges every 5 years, and along with all the innovation, all the private things that people are doing, and all the new technology and new renewables. And we can do this. So anyway, that's it. This is for the Doomsday Debunk group on Facebook. To join us, either if you're scared, or if you want to help people who are scared, or if you're good at fact checking, you want to find out about these things. And do be sure to read the rules at the head of the group. I'll put a link in the video description to Doomsday Debunked on Facebook. And do subscribe to my channel if you want to watch more videos like this.